Hello friends, in this session we will be talking about coordinate geometry. So let's first of all understand what do we mean by coordinate axes. Two mutually perpendicular lines or axes through any point which we call O in a plane form coordinate axes or axes of coordinates. So if we see this, we have this one line which is in the vertical direction and this line which is in the horizontal direction, this one and this one. So these two lines which are perpendicular to each other, which are drawn through this common point which is O here, and they lie in the same plane, they form the coordinate axis. So we are saying this these two lines passing through this point O and perpendicular to each other are forming coordinate axis. This one, the horizontal one, is called x-axis, and this one, which is the vertical axis, is called the y-axis. So although we say while we define, we say two mutually perpendicular, but conventionally we take a x-axis, the horizontal and the vertical lines as the axis. The point of intersection is called origin, and we generally denote it by O. The scale for this axis is positive on the right side of the origin. So if we're talking about the x-axis, on this axis it is positive on the right hand side of the origin. On the x-axis it is negative on the left hand side of the origin. And talking about y-axis, the upper side is positive and the lower side of the origin is the negative. For any point P in the plane, we draw perpendicular on x-axis and y-axis, say PM and PN respectively, to find its coordinates. Say for example, we have this point P here in the plane and we'll draw a perpendicular on x-axis, which is this, and we call this point M, and we draw a perpendicular on the y-axis where we call this point N. So PM is perpendicular to x-axis and PN is perpendicular to y-axis. Now the distance of this point M from the origin, so we are saying this, if we call this origin as O, then OM, this distance is the x coordinate of the point P. Let's denote it as this. This is how we denote a point P on the coordinate axis. So this OM, the distance of the point M on the x-axis, is the x coordinate, or it is also called abscissa of the point P. So if you are saying the distance is x, then we put it here in the representation of the point, and abscissa is the distance of the point from y-axis. So we can say this distance OM is the distance of point P from the y-axis, which is called abscissa. The distance of point N from the origin, which is ON, this distance is called the y coordinate or ordinate of the point P, and we represent it by y. Now this ordinate is the distance of this point P from the x-axis. The distance of the point from the x-axis is called ordinate, and the distance of the point from the y-axis is called abscissa. The point is represented, as we just said, as an ordered pair x, y. X being the x coordinate or the abscissa of this point, and y being ordinate or y coordinate for the same point. This system of writing every point in a plane as an ordered pair is called Cartesian coordinate system. So we write every point in a plane by an ordered pair. and this system is Cartesian coordinate system. So friends, now let's look at the important points about the coordinate axis. So we know that origin of this coordinate axis or coordinate plane is represented by O, which is 0, 0. Any point P is represented on the coordinate axis by an ordered pair x, y. Abscissa, which is this x, is the distance of this point from the y-axis. So this distance is x, and this distance from the y-axis is the ordinate, which is y. Abscissa of every point on the x-axis, on the y-axis, sorry, is 0. So we are talking about, say for example, we take this point or we take this point. So any of these points, the distance from the y-axis is 0 because they are lying on the y-axis itself. So abscissa for all these points will be 0. Similarly, ordinate of every point on the y-axis, say we take this point, we take this point, this will be 0 because its distance from the x-axis is 0. It is, this point is lying on the x-axis, so its distance from the x-axis being 0, its ordinate becomes 0. Quadrants of a plane. Two axes divide a plane. This is the plane, this complete box is the plane, and this axis is dividing this plane into these 4 parts, which means 4 quadrants. Now if a point P, X, Y lies in the first quadrant, this is the first quadrant, here X, now this point is, we know, represented by an ordered pair X, Y, then this X and Y will be both positive, both greater than 0 in the first quadrant. This is the second quadrant. In the second quadrant, we know, we just said that on the left hand side of this origin is all negative. The x value is negative, which means the point lying here in this quadrant, any point lying in this quadrant will have negative x, which means x will be less than 0 and y will be greater than 0. This is the third quadrant. In third quadrant, if we see, we said that below this 0 line on the y-axis is all negative. The y value of y is negative, and fx being on the left hand side, again negative, which would mean that both x and y would be less than 0 in the third quadrant. And this is the fourth quadrant. Here this is below the x-axis, below the origin, so the value of y is negative, but it is on the right hand side of the origin, so its x is positive. So x is greater than 0 and y is less than 0 in the fourth quadrant. So friends, now let's look at the distance formula in coordinate geometry. We have this theorem which states that distance between 2 points, say A and B, which A is represented by x1, y1 and B is represented by x2, y2, is given by this formula x2 minus x1 whole square plus y2 minus y1 whole square root. Now we are going to see how do we arrive at this formula, and then we'll be using this formula to find out the distance between 2 points whose coordinates are given to us. So now from this point we draw perpendiculars from both the points A and B. We draw perpendicular to the x-axis to meet the x-axis in point C and D respectively. So we make AC, which is perpendicular to x-axis, and similarly we draw BD, which is perpendicular to the x-axis. We draw another perpendicular from A to BD such that it meets BD in E. So now we have AE perpendicular to BD. So we are saying this angle is 90, here this is 90, and this is 90. Now in this right angled triangle ABE, we have AB square is equal to AE square plus BE square. This is by Pythagoras theorem. So what is AE? AE is nothing but the distance of point E from the y-axis minus, which would mean this distance minus the distance of point A from the y-axis. Now distance of point E from the y-axis is x2, which is same as the distance of point B from the y-axis. Similarly, the distance of point A from the y-axis is x1. So AE becomes x2 minus x1. Similarly, BE is the distance of point B from the x-axis minus the distance of point E from the x-axis, which is y2 minus y1. So knowing this, we put this value in the Pythagoras theorem, saying that AB square is equal to AE square plus BE square. So we get AB square is equal to x2 minus x1 whole square plus y2 minus y1 whole square, then square root of this whole. And this is what we wanted to find out, the distance between A and B. So this is the distance formula, which is based on the coordinates of the points. So friends, now that we know the distance formula, let's try to understand what is the use of it. Where do we use this distance formula? The obvious use is to find the distance between two points whose coordinates are given to us, or if we know all the vertices, or in fact the coordinates of all the vertices of a figure, then we can find out the sides of that figure by finding out the distance between two adjacent points. Now in addition to this, this formula is also used in finding out if 3 points can form a triangle or they are collinear. So this is very important use. Now if the sum of the, say for example we have these 3 points. Now if the sum of distance between two pairs, say for example the sum of distance between these 2 points and these 2 points is equal to the sum of the distance between the third pair, then the points are collinear. The points can be collinear only if the distance between these points plus the distance between these 2 points is equal to the distance between these 2 points. Otherwise, the points cannot be collinear, because for a triangle, the sum of any 2 sides has to be greater than the third side. So this distance formula can help us find out if the 3 points given to us are collinear or not. We can also find out if a quadrilateral is a square or it is of any other type. How? If all the 4 sides are equal, that would mean distance between the 2 adjacent points are equal and the diagonals are also equal, then the quadrilateral has to be a square. The quadrilateral will be a rhombus if all the sides are equal but the diagonals are unequal. So we can distinguish whether it's a square or a rhombus. Given the, of course, in these two, we are given the coordinates of the 4 vertex of the quadrilateral. We can also find out whether it's a rectangle, because if the opposite sides are equal and the diagonals are equal, then it's a rectangle. It's a parallelogram if the opposite sides are equal. Parallelogram but not a rectangle will have opposite sides equal but the diagonals will be unequal. So we can find out if a given quadrilateral is a square, rhombus, rectangle, parallelogram, and so on. So these are some of the uses of distance formula, and they are used in the higher order problems to find out these kind of things and then use it for finding out the other things. Friends, I hope you enjoyed the session. If you find it useful, please like it and share it with your friends. You can visit us at our Cool Smart Learning website and post your queries there. And please subscribe to the Cool Smart Learning channel for getting updates on the new sessions. Thank you.